Table 6, what did you get for table A when the input is 4? What's my output? 32.5. It's allowed for it to wake up. All right, table 7, did we get an output for when the input's 25? What is it? 190. Both of you tables are correct. All right, now, if you would put 40 right here, you didn't notice that the table skips. At first, the X's are increasing by 1, and then all of a sudden it increases up to 25. So you had two options. You could have continued the pattern all the way up to 25. Not sure if that's what table 7 did. Even if they did that, they got the right answer, didn't they? So as long as you get the right answer at the end of the day, that's all that really matters. But on a test, that's a really easy way to make a mistake. So on a test, it would be better to recognize the pattern, recognize what type of function that has to be, and then make an equation so that no matter what X is, you can solve for it still. So table 8, can you tell me what the pattern is in the table? It adds 7.5 each time between the Y's. All right, for the X's, it's going up by 1 up until here. But usually when we're looking for patterns, we're looking more in the Y's, because that'll tell us what type of function it might be. So table 9, if it's adding each time, what type of function is that? It's linear. When I graph it, it'll give me a straight line. So if you don't know that by now, maybe highlight it, star it. Table A is linear because it's adding the same amount each time in the line. Table 1, are you able to tell me what the formula is for linear equations? Y equals mx plus b. Class, in y equals mx plus b, what is usually replaced with numbers? Don't overthink it. So again, I'm talking to all of you. In y equals mx plus b, what is usually replaced with the number? Harley? The b and what else? The m. So like that has been really like drilled into you probably since middle school. So like that, you guys were easily able to tell me. I'm sure a lot of you already know M is for slope, B is for y-intercept. So if you can identify those two things, then you can make the equation and then you can just plug in 25 and get your y. Okay, so let's start with what I think is the easier one, the y-intercept. Table 2, can you tell me what my y-intercept is based on the table? I feel like this lesson is a lot of review from like yesterday's lesson. So there's not a whole lot that's new in here. It's just kind of like repetition, right? Repetition is the mother of all learning. So y-intercept, we mentioned how to find it yesterday. So I'm going to ask the whole class, don't tell me what the y-intercept is, but how can I find it from a table? The y-intercept is whenever x is 0. So then table 2, what's my y-intercept from this table? 2.5. So if you don't know that, maybe start it highlighted. We talked about it yesterday, but when x is 0, that y is your y-intercept. Right, so there we go. So when we're filling out this formula, so that no matter what the x is, I can just solve. My y-intercept's gonna be 2.5. Now I need to figure out what my slope is. And there's lots of formulas that I told you you need to memorize, but just think about it. Slope is what it's changing by each time. So table 3, what is it changing by each time? 7.5. And it's increasing, so it should be positive. And now I have an equation that represents this function. I can just plug in 25 for the x. So all of that in my calculator, and it does give me 190. That is true. At least from what I remember from earlier. So feel free to check in just in case. All right, questions on that? Or when in doubt, if there's no other way you can figure out the answer, continue the pattern of the 25 times. Do what you gotta do. All right, now table 3. What's my output when the input is 4? For the second table. 640. Table 4, were you able to get this output at all? Okay, even my answer key, it didn't give me what the output is, so that means it's probably too big of a number, but it did give me the formula for how to get it. So let's see. What type of pattern is going on table 5 in this table? Yes. Okay. All right, I'm trying to write this down, but as you can see, the Wi-Fi is glitching. It's like waiting, but you're right. If you're trying to find a pattern, just think of like all the ways you could go from this Y to that Y. You could try adding, but for it to truly be a pattern, it would have to be consistent throughout, right? And here it's not. 10 plus 7.5 is not 40. So then it must be doing something else each time. So it's not adding, it's also not subtracting because the number isn't getting smaller. What's something else I could be doing? Yes? Multiplying, and if it's not easy, thank you. If it's not easy to see what it's multiplying by, like I get it, I can't think of what to multiply by 2.5 to get 10. But look at like, what can you multiply by 10 to get 40? By 4, and then see if that's consistent throughout. 2.5 times 4 is 10. 40 times 4 is 160. That times 4 is 640. Now, try following the pattern all the way up to 25. Your calculator stops at some point, the number is too big. But should it ask you, like it will on your constructed response for sure, you should probably make the equation to make your life a lot easier. So if it's multiplying each time, table 7, what type of function is table B? Thank you. It is exponential. If it multiplies each time to get to the next value. What's our format for our exponential functions? Now I want someone different to talk for your tables because we've already done like one rotation. So whoever spoke last, just, sit out this one. Table 8. What's my format for my exponential function? that are looking at your old notes, maybe look at your learning targets.
Y equal APN.
Good. Y equals A times B to the X. So like how a lot of you already know linear is Y equals MX plus B. You need to know exponential is Y equals A times B to the X. What gets replaced with numbers usually in this one is A and B. B is not going to be y-intercept this time. Does anyone remember what B is going to be in this one? What was that? No, it's not going to be my y-intercept for this one. My common factor. B is what I'm multiplying by each time to get to the next number. So what did I have to multiply by each time in this one? 4. So when I'm making this, it's gonna be y equals, I'm gonna leave some space for the a, 4 to the x power. Now, who remembers what a stands for? Initial amount. What's my initial amount in this one? 2.5. On a side note, that happens to be your y-intercept. Always, just so you know, your initial amount is your y-intercept. But yeah, now I have the equation. Now, if I wanted to find my output, what do I have to plug in for the x? The input, which this time we're trying to figure out when x is 25. And that's really all you can put in for this right now. I mean, I'll show you what it looks like in the calculator, but it's too big of a number to fit in that table. So I would just probably write down how you get that answer. But most of the time, like on your test, it will give you a value and you just put that down as your answer. But just for fun, let's make sure we all know how to use a calculator. All right. So it looks like this when you type it in because the number's so big. They put it in scientific notation. So if it's times 10 to the 15 power, they would want you to move this decimal point to the right 15 times. Like that's how big of a number it is. Your calculator doesn't have that much room on its screen. So it's just a really big number is all you really need to know right now. And that's how you would find it. So questions, comments, concerns? All right, so it's a lot of repetition of things we've already talked about. So, you know, just try to start ingraining it in your memory. It'll make your life a lot easier for geometry and algebra 3-4. But today we're still continuing to explore exponential decay. So being able to explain the meanings of A and B, we just covered that in the warm-up. A is your initial amount, B is your common factor in your exponential function. Also being able to find the growth factor from a graph and writing it in an equation. And graphing equations that are exponential decay. So I record all the time, but should you ever need to work ahead or just want like other examples, they're there. Puzzle piece today will be lesson 5. And you won't have another assessment until Monday, but it'll be everything we covered this week and from Friday. So do make sure you're staying caught up, even if you're absent, like go back, watch the video, take notes, do all the stuff. But additionally, tomorrow I am taking my team to compete in the state championships. So I will not be here. However, you always have stuff to do. So make sure you do the stuff. Otherwise, I'll know when I come back on Friday who actually watched the video and who didn't. But the slides are in Schoology. The sub will have a copy of it, and they'll have a copy of the seating chart. your picture so that if there's any like shenanigans going on, I know who it was exactly. But it's all there. Basically, you're gonna watch the video lesson, ideally on your own Chromebook. If that doesn't work, the sub will know how to put it on the TV. But anyway, watch it at your own pace on your Chromebook. You will have a note sheet. It'll be on the counter where it usually is. And you will complete it, take pictures of both sides and upload it to that link. That's how I hold you accountable to it. Even if you're gonna be absent tomorrow, you still need to upload your note sheet for that one. Then you have a practice. If you use time wisely, you should be able to get that done. Maybe have a little bit of free time, but there's no reason you should be like on your phone all hour. And if you do, that's on you. I mean, you'll just have to make up the lesson on your own time. Questions? Alrighty then. Also, I've been asked about like how to get your grade up. Know that I do update grades like within 7 days of when you turn something in, usually sooner. But right now, like this week, I don't have tutoring. Tutoring will start for me next week. But you can do test corrections on the more recent quiz. So I'm in Schoology. If you click on the welcome folder and scroll to procedures for test corrections and retakes, this is how you can get your grade up. All right, on your separate paper, do the corrections, show work or provide an explanation for why your new answer is correct. You don't need to rewrite the whole thing. I can see what you got wrong. And then you just take a picture, email it to me. If you want to do a retake for full points back, then come to tutoring starting next week on Wednesdays. But yeah, that's pretty much it. Questions? All right. So this will probably be our only activity we do. There's multiple parts. It does kind of take a bit. So the algae bloom. In order to control an algae bloom in a lake, scientists introduce some treatment products. Once the treatment begins, the area covered by algae A in square yards is given by this equation. So just looking at how the equation is set up, does that look more like y equals mx plus b or y equals a times b to the x? So it looks more like our exponential function. So keep that in mind. Time will be measured in weeks. So based on what you know already about exponential functions, you should be able to tell me what the 240 represents and what the 1/3 represents. Put that on your paper, talk about it in your groups. Then you're going to create a graph to represent the equation when t is 0, 1, 2, 3, and 4. So consider organizing your information in a table. T or Y, same difference, they're both inputs. It's going to be 0, 1, 2, 3, and 4. And you're going to use your calculator to find the outputs given this equation. So really, unless you're reading the answer off the calculator screen, I don't know how you would do it without one. So have a calculator out. Everyone needs to practice the calculations. You can work together in your groups. But be able to answer 1 and 2 for right now. Table 5, what does the 240 tell us? When the x is 0, that is true. What about in the real world situation, like 240 what? 240 square yards is what the algae started at. And that is true. It is when the x is 0. Because also, if you did the calculation, and you put in a 0 for the t, anything to the 0 power is 1. 1 times 240 is 240. So that should have been your first output when we exited for T. So good, table 5, what does the 1/3 tell us? Would the algae be increasing or decreasing over time? Table 5, table 6. Decreasing, so it's decreasing. There's 2 ways you could say this. You could say that the algae is decreasing by a factor of 1/3. That's one way you could say it, like factors what you multiply, and you are multiplying 1/3 each time, so you could say it's decreasing by a factor of 1/3. Or if you remember like what we talked about yesterday, another way to write the exponential function is like this, where it's like 1 minus the growth rate. So if I'm timesing by 1/3, another way you could say this is I'm losing 2/3. Because 1 minus 2/3 is 1/3. So you could say it's decreasing by a factor of 1/3, or you could say it's losing 2/3 of its volume, or however you want to say it. It's losing 2/3 for each week. So what it's losing is the decay rate of 1 minus that. 1 minus 2/3 is 1/3. You could also say decreasing by a factor of 1/3, because factor is what we multiply. I know, but you want to have the right value for B, so that's how you figure it out. Questions so far? If both ways are correct on how to say it, you've got to say it specifically those ways. Table 7. What is my output when the T is 1? Sorry, one more time. 80. Table 8, what's my output when the T is 2? Approximately. 26.6. I'll check if the rounding is right in a second. But we'll see. Table 9, what about when T is 3? 8.9. And table 1, what about when T is 4? Done?
2.5.
Okay, and I think all I need to check is the rounding. We might have some rounding issues, but I think we got it. I think everyone in this class knew to use a calculator, otherwise you can't get the answer. At least not easily. So it gave you the equation. And it told you what's the A when the T is this. So basically, what's my Y when the T is 0, 1, 2, 3, 4. 0 we already knew because that's my starting amount. That's correct for when the input's 1. This, I think we just need to fix the rounding. If we're rounding to 1 decimal spot, it'd be 26.7. When the T is 3, 8.9 is correct. And when the T is 4, if we're rounding to 1 decimal spot, we would have to bump it up to 3. Because this is a 6, so it would be like 3.0. But close enough. When we make the graph, we're going to have to estimate anyway. Question so far. Do we know how to use a calculator? If you're getting values other than what we're getting, then that just means you don't know how to use your calculator. That's an easy fix. So just make sure you speak up at some point. Now we're going to make the graph. So what should go on my x-axis? What is the x representing? time in weeks. And look at our table of values, that'll determine how we scale it, I guess. So my weeks, my X's go from 0 through 4. Could I label these by 1 if I wanted to? You could also do 0.5 or whatever else you see fit, but it needs to have at least 0 through 4 on the X. My Y, which represents square yards of algae. Look at what our Y's go to. Goes from 240 to 3. So however you want to label these is up to you, but it needs to have 240 and up to the 3. Okay, so figure that out. I'm gonna freeze my screen and you will attempt making the graph yourself and plotting those points. So go ahead and do that. I'll give you about 2 minutes. If you finish that early, try number 3. How many square yards will the algae cover after 2.5 weeks? Yes. All right, so when you do your practice later, consider using the same strategies we did. Consider making a table of values to organize your information so that when you make your graph, it's easier. I did the tick marks down here by like 0.5, I guess, just so it's a little more spread out. Doesn't have to be, make it make sense. And then for my Y's, I counted by 20s for each tick mark, but I only labeled like every other one. So that doesn't look good. But it makes sense, like they count by the same intervals. So we're good. You should have points that match basically your table of values. Remember, these are all coordinates. So find 0 on your X, go up on your Y 240, put a dot there. Find 1 on your X, go up 80, put a dot there. The rest are kind of having to estimate, but 27 would be somewhere between 20 and 40. 9 would be somewhere between 0 and 20. And the 3 would be closer to the 0. It looks something like that. It's decreasing at a really fast rate over time. Questions on that? Okay, so last part. If I want to know how many square yards will the algae cover after 2.5 weeks, what do I need to do? Can I just like average, I don't know, these two and get the right answer? I know it should be somewhere between these outputs, right? But how do I get the exact answer I need? No volunteers? So reread it. And then reread what your equation represents. Like the variables specifically. Does that 2.5 need to go in for the A or the T? Is it 2.5 square yards or is it 2.5 weeks? So then to find how many square yards, I just need to make that T 2.5. Just like how you filled out your table of values, you plug it into your equation. Like this. Right? If you're, I don't know, using a calculator that doesn't let you put in everything at once, make sure you do the exponent before you multiply. But now I'm checking for when it's 2.5. So your answer should have been about 15.3 or 4. Do we know how to round? 15.4 is how you round to 1 decimal spot. Good, any questions? Okay, on the back side, we're not gonna do the whole thing. I just want you to do number 5 on the back. To practice finding the pattern in the table and making the equation. Tomorrow, when you do that lesson on your own, you're gonna find an easier way how to find what they're multiplying by each time. So please do watch that lesson tomorrow. But let's just see if we can practice what we learned today by doing number 5 on your backside of your notes. That's it. Try completing the table. I'll make sure to go over it, I'd say in about, I don't know, 5 minutes, which is a ton of time. Do your practice in the meantime, once you've attempted this one. So attempt, and then your practice is a 5.05 in Schoology. Your task was to try and fill out this table. Who thinks they have it for when X is 4? What's my output? Okay, one more time. All right, let's see if that's right. Did anyone get for when X is 5? What's the output? What was that? Okay. So tomorrow, when you watch the video, you'll find a really easy way to figure out what they're multiplying by, if they're multiplying by something. But you can definitely tell it's not like they're minusing 10 each time, right? Like that's definitely not what they're doing because it's not consistent. So that's where you kind of like explore, what are they doing? Did we figure out what they're multiplying by? Right? Okay, what did you put that they're dividing by?
1.1.
Let's see. Because sometimes like it looks like they're dividing and you can phrase it different ways. So let me see if that still gives me the same answer. So based on the rounding, that's not like the way. So how about I just kind of tell you, because I feel like otherwise it might be hard to do some on your homework without knowing. So I know this answer is close, but I don't think it's that one. If you can't easily figure out what they're multiplying by to get to the next number, here's how you can figure it out. Take one of the numbers and divide it by its previous term. 90 divided by 100 is 0.9. And then it really could work for no matter where you look. If you do 81 divided by 90, its previous term, you also get 0.9. And that's what they're multiplying by each time. So then when you continue the pattern, 72.9 times 0.9. So just to show you, so you know I'm not just making things up. Take a term divided by its previous term, that'll give you your common factor. Since it's just going to 3, 4, 5, we can continue the pattern. So if I do 72.9 times that by our common factor that we just figured out was 0.9. 4 should be 65.61 right here. And then times it by 0.9 again will give you your when X is 5. And that's, if you round it, 59.05. So now you have another little thing that can help you. Questions? Okay, you still have time, so like, please wait to back up till 10:19. You can knock out your homework. I think it's like 6 problems in 6 minutes. Probably, so just do that.